And this is your final helpful video here. This one is particularly helpful. I want you to imagine that we have now taken the system from before and put it on top of a set of rollers, and I'm going to pull it now. And I want to know with what force must I pull in order for the object on the top here to appear to be motionless relative to the cart. So essentially, we want it to appear to be motionless. So what does that mean exactly? If it's motionless, that means it's moving with the same kind of motion. Um, what's the typical tendency of this object on the top? The typical tendency is to accelerate. So really what we want is we want the acceleration of the entire system, and by system I mean the big giant system, including the cart, to be equal to the acceleration of the little system. And the little system, well, that's the system of this mass, the pulley, this mass, right? Because if we can pull this cart in such a way that this object falling here doesn't really have an opportunity to fall, or at least as this object pulls forward, there's no increase or decrease in the length of this cord, then the system will appear to be motionless. And we'll just have this object flying through the hallway or whatever it is with this on top and not accelerating down. Alright, so from the previous problem, we got that the acceleration was 5, but let's do that again just in case. We have a downward force of gravity of 150 newtons this way, and it's frictionless, so we have nothing back. So our F net of the little system, F net is equal to 150, which will equal the mass of the system times the acceleration of the system. So 150 is 30 times the acceleration. So acceleration is 5 meters per second squared. So really what we're saying is we want the acceleration of the big system to be equal to 5 meters per second squared. So acceleration of the big system is going to equal 5 meters per second squared. And so what's that going to mean? Well, F net will equal mass of the big system times acceleration of the big system. The mass of the big system, oh, I guess I didn't give that to you. The mass of the big system, we're going to say that this is 50 newtons here, or 50 kilograms here. The mass of the big system is 50 plus 15 plus 15, so that's 80, and our acceleration is 5 here. So that means that the net force in order to get this to move is going to have to be 400 newtons. So if we pull with 400 newtons of force, then the acceleration of the system will be the same as the acceleration of this upward mass if it were to be allowed to fall.